Happy to hear. My name is Simon Wössner. I'm happy to challenge Brendan for contest in spelling or because my last name is also some challenges here. The introduction of subtask A was basically wrapped up by you. Most of the issues I wanted to bring up were already raised. Which comes from how do we integrate the relatively new but very trendy word right now, the embodied energy, LCA, carbon emission, like terminology into the planning process. How do we manage to bring that from what's happening often right now after the building or after the construction process is done in terms of a certification afterwards, like the common certification systems, more into actually planning and decision based on LCN. And it was also mentioned, EPDs, there's a little trust right now. I would pronounce it differently. There's a lot of insecurity about how to deal with them. I think that is probably better wording for it, and that's what we looked here in subtask A, and I'm really happy that I can be here representing my colleagues and share some of the thoughts we have. So first of all, in that subtask A, we're looking into scenarios, strategies, and roadmaps, which is, I think, kind of crucial right now to bring that relatively new terminology and also the idea of what we heard here about comfort. How do we integrate that with an LCA approach? How we do get that together? And how can we support and look at methodologies into how to look at LCA, embodied energy, and also how do we make it as a design criteria? How do we achieve that? And therefore, first of all, we have looked at the status quo, what is out there, how do the different countries do that? I mean, that's also the nice thing always in that international project, that we can look at different approaches in different countries. And while I think the lighting simulation, energy calculation is more or less standardized right now over the years, because there's a long history in how we do things, radiance, energy losses around a long time. But LCA is not standardized, but commonly approached in the different countries. So that was the first thing, that we just see where are we standing, what is available, how is the way forward, are there regulations, and I think, Helen, you mentioned there's a little consideration in standards. I mean, the European Union is now looking with the Energy Performance Building Directive into nearly zero emission buildings, not energy buildings, zero emission buildings. So it is coming, but it is slowly coming. But that is, I think, the next step, and therefore we also need to be ready. And I think that's also one of the challenges we're having right now, to bring that LCA assessment from that relatively small group of LCA experts into a wider application. And that is what is one of the main challenges to our understanding. And that's what we also want to address here in that subtask A. Therefore, after we looked at the status quo, we want to look at a catalog of scenarios, how to approach that design criteria here, how to move away from the EPD, the Energy Product Declaration, Environmental Product Declaration, to actually, again, planning criteria. That goes then along, out of that, we want to have a framework for the rating scenarios, and then, of course, disseminate that in some design guide and strategies and roadmaps. So let me quickly elaborate on how we want to get there. First of all, I mean, we're here in a teaching research facility. I don't want to go into teaching here, of course, but just some words because they pop up all the time again. So the life stage of embodied energy, what we're talking here about is the production and also the construction phase of the products, but also then the end of life, the reuse, the transport, the waste disposal, and so on. So that is what is added to, if you only look at the energy consumption of a building, which would be part of the operational carbon thing. Now we're also looking, what does it take to produce the materials, to bring them to the construction site, to the assembly, to the fabrication halls, but then also what does it mean when operating. We have also some like terminology which is popping up, that cradle to gate, cradle to site, cradle to grave, end of life, the cradle to cradle, the reusing, and within that we're looking at the different stages. So not only the operational, but also what does it take, how much CO2 does it take, or energy does it take to produce the products, to assemble them, and so on. So that is that change of things. And also, it is important then to understand, if we heard already about the EPDs, they are not covering all of that aspects. They're usually cradle to site or cradle to grave, but without the operational carbon or only some of that. So there's also a lot of words going around which are also quite new to that kind of thinking, design thinking then in the end. So in an ideal world, what we have here, if we talk about energy and costs, we're quite good at that over the years. And there's that very nice chart comparing the different options for daylight contribution to spaces associated with some rough costs, just to give an idea what other things are there around. Maybe also what to think about other options. And in the end, we want to have something similar like that, just to give people ideas, what else can you do in terms of daylight, and again, with a focus on CO2 or green warming potential. But the thing is, it's not that easy. So there's, if you only look at an EPD, which does not say anything about how that product is used or what's happening in the building, there's a lot of decision and paths you can take, and it's very, very hard to find a way to determine how the impact of that products are, and the EPDs are not the way, or currently, at least how they are currently formulated, to evaluate what that means for the space. And also a decision between daylight and electric lighting, you can't do that on an EPD level, so you have to change something like that. So that is what we want to get at the end. So again, I mentioned already that survey that was done to get a first overview about the status quo. We have received 15 surveys back from different countries. We just wanted to get an idea how we're standing in terms of methodology, about data, about the general overview. And we found out that it is very, very scattered, very different. So we have found a lot of databases, some are free, some are paid, but they all had different scopes, different meanings, different settings, and you can't use either the one or the other because they are not comparable to each other. So there's a lot, you have to know what you do. Bringing me back to that, what I said about that small pool of experts, auditors, they usually know what they do, but now on the large scale application, we see there's it is not a clear pathway yet, which is just to be went on, and then you can do your life cycle assessment. And we can also see, and that's quite interesting here, that right now in terms of electric lighting, there's very limited data sets available. So also if you want to compare different scenarios to each other, there's basically nothing to compare, because China has one data set, Denmark 5, Germany 16 at least, but it is also a very limited number of options where we're looking at. The facade components are even scarce than that. So also there is some improvement possible. Just to give you an idea, and I already see I need to speed up a bit, that is a Belgium database. Here's an aluminium profile for window. Some information are giving there. And I would just want to quickly draw the attention to the functional unit. That's the surface area. That's what the influence is broken down. But just the square meters does not say anything about how that is used in the room. And also, if we talk about comfort, just the square meters of window does not say anything to that. So that is also one of the things we have to look at. And then, of course, we have the EPD. So that is an EPD for lighting. It clearly describes under which circumstances it was measured, what is included. I don't want to go into the details, but then you get a lot of numbers, which you also have to know how to work with. Again, difficult. What is all in there? So it's a whole new world. Talking about similarities, we also look at the trading prices for the CO2 certificates in the different countries that were participating. It is not unique, not uniform. It is very different, and I think that is the best way to describe the situation on the LCA right now. It is very, very scattered, very different approaches, and it's not unified. And that's something that is just my main message from the status quo for the subtask A. It goes along if you look at the mentioned luminaires from the few databases we found. And if you look at the last comment, that's the green warming potential for them. And so at the first glance, you look at that and say, okay, the one is 20 kilograms CO2 equivalent, the other one 517. There must be something either wrong or there's a huge impact. Now it's not, it is actually based on the different functional units. Some of them are related to hours of usage, some to pieces, some to, not square meters, that doesn't make sense, but it is really different also in the approaches, and also in the same database, some products have those functional units and reference areas, reference units are very ununique, well, very scattered. Again, you have to look very much into detail what you're looking here, and that's also something we want to address, maybe to get that more unified or more get different functional units to assess the LCA, or again bringing it more to a design thing. Not want to go into all of that, but some of the things is, so we only have very limited data are available, especially for the lighting products. I mean, the EPDs are coming, but they're also not the only solution to everything right now, but there's some movement at that stage right now. But then we also need to look at, do we need EPDs or EPDs for group of products, type of components or something like that. Not to, you know, at the very first design stage, you're already having to say, I want this project or that product to have some flexibility here. How do we evaluate the level of carbon emissions, not only on the product side, but also on the system side, in the building, in the use in the building, which is a very key point. And then also, we also have to see what does it mean to produce those EPDs if they are crucial. What does that mean for the manufacturers? I mean, there is a lot of stress right now on them to put out those EPDs, especially for the smaller companies. That is even probably a higher burden, but that has to be done. We all will have that combined in a report, which should be available fall of this year, just to see again what I have briefly told you right now in a more elaborate way. But then that brings me to the next thing, and that is almost everything I want to say here. But that is then the next stage where we think about going from the product stage into what is happening in the building. And the way to do that is that we want to link some scenarios. So we look at now probably new functional units also, which make it able to evaluate electric lighting versus daylighting. Electric lighting is way easier than the incorporation of daylighting, but look at those, what I mentioned with functional unit, like the rating, the unit of rating, so to say, in terms of energy, that would be the kilowatt hours per square meter or year, something like that, to break down the CO2 impact on new functional units, not square meters of glazing, but installed wattage of electric lighting or something like that. So how to do that? And therefore, we want to look at different types of buildings, office building, and then look at different materials and bring them together. So those functional units with specific solutions, and see what we can learn out of that. That is our next step in order to find those rating criteria, functional units that are more suitable than just square meter or pieces of luminaire or something. So we want to look at, of course, electric lighting, but also on daylight, the use of daylight, also to be able to bring those together, and also to be available or to be possible to evaluate the use of the one or the other or together in not only energy or daylighting simulation, but also from a CO2 green warming potential perspective. Exactly. Daylighting, again, electric lighting is quite easy in that thing. Not that it's easy, but it's easier than the incorporation of daylight. But that is, of course, also one of our ideas and things what we want to look at. And that brings me to the end of the short presentation of what we're doing in subtask A. And I'm now very happy to introduce one of my colleagues here, Marvin, who will tell us something about the sustainability at Hella.
You have time for a quick question? So, okay, maybe later. You talked about that. You didn't go into the roadmap in details of the strategic strategies, right?
Yeah.
I mean, so I'm just curious, have you thought about, besides talking about the daylighting, lighting area, about how that interfaces with the rest of the building, and putting it in context about like how, it's like being able to reach beyond just this area and explaining how critical it is to work with other parts of the building. Like, have you thought about that as part of your road mapping strategy?
Yeah, absolutely. Okay. That is the key piece actually of the not only looking at the lighting itself, but also the integration of lighting into the complex system building. So also the influences back on heating, cooling, and so on. So of course that is.
Another one phrase we've been using in the U.S. a little bit is, why do windows matter? Right. Yeah. So trying to get that messaging out, why it's so critical, right? That's
exactly that's what we're looking for, and that's I mean, we're not there to promise that we will achieve that, because it's very complex. But that's what we exactly try to do with the scenarios, to look at exactly that, and then also incorporate the comfort, because lighting is all about comfort. But how does that comfort work in terms of the building as a system, as an energy system, as a functional system?
Thank you.